Okay, so now moving on to the next presentation. This is coming from, again, the manufacturer. This is TWSolar. We have Jason Xia, Director of Module R&D Department at Tongwei. He is going to talk about downstream technology development at world's leading silicon producer. Jason, the floor is yours.
Thank you for the introduction. I will share my screen. Hold on a second. Can you see my screen?
Yeah.
Okay. Thanks for the introduction. Today, I will give a presentation on high-efficiency N-type module roadmap for the PV industry. My topic will be divided into 3 parts. Firstly, I will give introduction about Tongwei. Go through the Tongwei's PV industry chain. We have the largest polysilicon capacity in the world. The annual capacity now is 420,000 tons and will reach around 1 million tons in the next couple of years. Our ingot and wafer capacity are 50 gigawatt and will reach more than 47 gigawatt in future. Our solar cell capacity right now is 90 gigawatt, also ranked #1 in solar cell shipment for 6 consecutive years. Cell capacity will expand to around 150 gigawatt in the next year. Module level, we are ranked in Tier 1 and have 55 gigawatt annual capacity in this year, and plan to have more than 100 gigawatt in future. Our cumulative cell shipments have reached 160 gigawatt in H1 of this year, which is the first in the industry. In H2 of last year, Tongwei announced plans for further expansion into PV module business. As mentioned before, we have 55 gigawatt module annual capacity and plan to have 100 gigawatt in future. We are the Tier 1 module supplier, providing PV solutions in residential, commercial, industrial, and utility scale to more than 40 countries across Europe, Latin America, Middle East, Asia Pacific, Oceania. Our R&D is distributed in 2 locations. Most of them are in Chengdu, Sichuan province. Technically, for HJT, we started China's first gigawatt HJT production line in 2021. And then we built a new R&D lab on advanced metallization, primarily for HJT in Sichuan, also in 2021. For TNC, means Tongwei N-type cell, we set up G12 size, wafer size, R&D line in 2020. We also have dedicated pipeline for IBC development and well-equipped parallel and HJT tandem developed lab. We spent millions RMB to build solar cell characterization lab. Till now, we have 2 module R&D pipelines in Anhui, Chengdu for province, city for single-lane and half-cut module technology development. Meanwhile, the 2 module reliability testing lab are both STINAS certified. We are going to have a new reliability lab with area of 7,000 square meters in the next year, which should be the largest module reliability laboratory in the world. Tongwei have over 600 R&D researchers covering all PV technology fields. Tongwei has already published 1,822 patents by the Q3 of this year. Tongwei initiated TNC cell research in 2020 and developed the industry's first large wafer size PECVD polysilicon technology route. By 2021, mass production convention efficiency had reached 24.65%, with further improving to 25.3% in 2022 and 26.1% in October of this year. Tube-based PECVD technology developed by Nantong University, NID Micro and Tongwei has been twice featured in annual and monthly covered articles of progress in photovoltaics. The domestic cooperative development achievements in tube-based titanium oxide plus poly closed the industry gap and brought cut-edge development and industry-leading production progress of TOPCon cells. And SE technology helps to improve TNC cell efficiency with frontside high square resistance, working for dense grid to improve open circuit voltage and current, backside dense grid to reduce the transmission loss, improving fill factor, and then achieve the purpose of improving cell efficiency. In December 2021, Tongwei optimized the PECVD poly route for mass production. In October of this year, average cell efficiency of 26.1% was achieved from mass-produced TNC cells, which was corresponding to module power of 585 to 590 wattage, or for M10 72 format module. And in Q1 of this year, when the G12R and G12 modules are put into the market, the module power will reach 620 and 705 watt, respectively. Because of higher biefficiency, lower annual degradation, lower temperature coefficient, TNC module can have higher power generation per watt than PERC module. Take a PV system demonstration in Hainan province in China, for example. Power generation per watt of TNC module is 3.34% higher than that of PERC module from March to November of this year in the field. Let's take overview of Tongwei's module products for the recommendation. Shingled all black modules and TNC black module for residential application, and M10 TNC modules for utility and commercial rooftop. Most importantly is the two new products on the right. One is TNC module with G12R cells of wattage up to 620, and the other is THC module with G12 HJT cells, and the wattage is up to 730. The first new product is TNC G12R module with wattage up to 620, as I mentioned before, and the module efficiency reaching 23.0%. Compared to the traditional M10 TNC module, the G12R TNC module improves 25 to 30 wattage per module and has advantages on transportation, BOS, and LCOE. Of G12R module is matching with the length of the container to maximize packing efficiency and reduce transportation costs. And the transportation cost reduction is around 4% for 40 feet higher cube container. Let's look at the PV system advantage of G12R module. Due to 66 pieces cells per module only, G12R module can have 9% open circuit voltage than traditional M10 or G11L module with 72 cells, which results in about 2 pieces more modules installation in one string in the field. That is 12% less string for the same system capacity. Also, due to higher power output, G12R module can reduce LAN space by around 9% compared to the M10 module. Considering advantages on string length and LAN space, we have calculated BOS and LCOE for utility systems in the world, such as Europe, Asia, South Africa, and etc. The average results show that G12R module can decrease by 1% for BOS, by 0.6% for LCOE than G11L module, and decrease by 2% for BOS and 1% for LCOE than the M10 module. The other new product is THC module with wattage up to 730 and module efficiency reaching 23.5% combined with G12 size, ultra thin wafer, bifacial monocrystalline silicon deposition, silver-free metallization cell technologies, and zero busbar module technology, which demonstrated excellent performance of high reliability, high output, and competitive cost. Tongwei began developing HVD technology in 2018, building its gigawatt level HVD production line in China in 2021. Tongwei pioneered the introduction of bifacial nanocrystalline silicon into HVD. And by Q1 of this year, HVD champion efficiency reached 26.49%. Tongwei built the first pilot plant to implement and develop copper interconnection technology, realized silver-free. Currently, the weight of the fingers has been reduced to less than 15 micrometer, enhanced the cell efficiency by 0.2% in comparison to the printing process. Our THC modules have achieved excellent performance, not only on IEC standard reliability test, but also combined aging tests such as UV plus thermocycling and UV plus damp heat, even 5 times IEC reliability test such as thermocycling 1000 test. The module power degradation is less than 2.5%. With HVD technology from wafer to module developing accumulation, we have break Tongwei's HVD module power record for 5 times in this year, from about 720 to 745 watt, which is certified by TWSolar. Finally, I will make a summary. Tongwei has achieved the first product shipments on both polysilicon and the solar cell in the industry, and are taking expansion on PV module business by initiating and optimizing the PECVD poly load for mass production, cell efficiency of 26.1% and module power of 590 watt was demonstrated for mass production level for 182 TNC technology. And we will launch 2 new products in Q1 of next year. They are TNC G12R module of the wattage 620 and the THC 210 module of the wattage 730 watt, which will present more values, power output, reliability, and LCO. That's all. Thank you.
Thank you, Jason. So I have one question. So, you showed that you also experimented with the screen printed copper metallic contact. So how far is this from the commercialization? So when do you expect the technology to be commercialized?
Yeah, we are doing the just I mentioned in the presentation. So we are now doing the R&D, and we will have the pipeline in the next year. If the if the performance, such as the cell efficiency, module power, and the cost will be competitive, then we will transfer it to mass production.
Okay. Okay, thank you very much. I think there are also a few questions in the chat window. Please stay online and answer these questions, while enjoying the conference. So I will move to the next session. Thanks a lot.
Okay, bye-bye.